Radical Dude here, and today we're going to talk about the quadrilateral family. Quadrilateral family. Quadrilaterals. That is a long word, and it's a nice word. So if any of you guys, when you start to have kids, maybe you'll think of naming one of your kids Quadrilateral. Be a nice name. All right, first of all, what is this? I think it's Greek. And the quad means four, and the lateral, I guess, means edges, sides. So it's four side. Any four side. So we're going to call it a four-sided polygon. Anything with four sides, 1, 2, 3, 4, or 1, 2, 3, 4. These are all quadrilaterals. And we're going to classify them. We're going to classify them by their parallelness. If you can you have three choices. Either their sides, opposite sides are parallel, or one pair is parallel, the others are not, or no pairs are parallel. So let's look at what that means. Okay, zero pair of parallel lines. If we have zero pair, that means you have something like that. Nothing is parallel. And the name for this is a trapezium. Trapezium. T-R-A-P-E-Z-I-U-M. There's also a name in a hand, one of the bones, I think, trapezium, but this is what it's called for mathematics. And the famous trapezium that we have, the most famous one of these is this one right here. It's called the kite. That's the most famous of the trapeziums, the kite. And no sides are parallel. That's one way to classify this group. Now let's do with one pair. One pair of parallel lines. One pair will make these lines parallel. Connect this here. This one is one pair, and it also starts with a D. It's called a trapezoid. That is with only one pair of parallel lines. And the most famous trapezoid that we can do in high school is the one that looks like this, where these two sides are congruent and these are parallel. It is called, same thing as trapezoid, but they call it the isosceles trapezoid. Okay, the isosceles trapezoid. There we have it. It's part of this family. And the last thing we can do is when we have two pair of parallel lines. First of all, it looks like this. These are parallel and these are parallel. Since these are parallel and these are parallel, it's called the parallelogram. Parallelogram. Which would be another great name if you're having a kid. Parallelogram. Come here, parallelogram. It sounds nice. Now, from the parallelogram, I could take it and straighten it out, make 90-degree angles. Straighten it out. These opposite sides are still parallel. And this one, of course, is called the rectangle. parallelogram and made all the sides congruent. So if I make this side congruent to this side congruent to this side, they're still parallel. These are parallel, these are parallel. This one is called the rhombus. Okay? Opposite sides are parallel and congruent. It's the rhombus. But don't wait for this one, because this is a bus that never arrives. Okay? And there is no rhomb train, although I've been heard they're working on one. So you have rhombus, you have the rectangle, and the parallelogram. Now, if we take this rectangle and make all the sides the same, or if we take this rhombus and straighten it out, we get one of the most famous shapes of all time, you've known since you were a little kid. It is called the square. And these are both, this is where it comes. So when you want to do how you relate these, you always go up. That means all squares are rectangles, but you can't say all rectangles are squares. Okay? Just like if this was the freshmen, you could say all freshmen are students, but not all students are freshmen. You can say all squares are rhombi. You don't say rhombuses. All squares are rhombi, but not all rhombi are squares. All rhombi are parallelograms, but not all parallelograms are rhombi. All rectangles are parallelograms, but not all parallelograms are rectangles. And it goes up. These guys are part of the quadrilateral family. So you can say all parallelograms are quadrilaterals, but you cannot say all quadrilaterals are parallelograms. So that is the entire family of quadrilaterals. I wish my family was that close. And anyway, this has been Radical Dude, and I hope you learned something.